cancer classification using multitask learning search from the idea to generalize classification across different medical imaging domains. In particular, there are some cancer types that machine learning and deep learning models have difficulty to learn given the limited amount of data available to train such models. This work focuses in multiple cancer detection using MedMin's version 2 dataset, which consists of 18 MNIST live datasets of 2D and 3D biomedical data. For the scope of this project, I decided to use 2D datasets exclusively. For data preprocessing, it was needed to implement a custom data loader that was capable to translate different MedMin's datasets into tasks. Since there was no similar component I can use publicly available. The goal of this project was to evaluate how well a multitask learning approach performs for the datasets where other models achieve an accuracy between 50 and 70%. As baseline, I decided to use an auto-sklearn model which automatically searches the algorithm and hyperparameters in scikit-learn package based on the task it asked to perform. To compare if using tasks conformed from different datasets will help to learn the distribution of some classes of malignant or benignant cells, I run my models with two configurations in mind. The first configuration splits training, validation, and test set in tasks conformed from the dataset to evaluate, and the second configuration where the training and the validation set consisted of tasks conformed from different MedMin's datasets, and the evaluation is done in a test set made exclusively of tasks from a dataset target. As experiments, I train using two architectures, a modified version of the MAML paper, which uses a deeper neural network as backbone to learn the complex features of the images with 3 channels. Similarly, I adapted a protonet to use a similar backbone and tested using different hyperparameters, including the quantity of datasets. For most scenarios, there was no considerable difference between training with one or multiple datasets, which led me assume there might not be some compatibility in the structure of the task when training with information of different datasets. To show the results, I choose as target a skin cancer classification, which data is contained in the DermaMin's dataset. As shown in the result table, the model with higher accuracy was MAML trained exclusively with DermaMin's dataset, which compared to the baseline doesn't achieve as high accuracy. My guess is that the model is not able to learn properly the feature of the images to perform a correct classification, so using a different feature structure like ResNet or EfficientNet might help my model to achieve higher performance. Finally, from the experiments run from this work, it is not possible to conclude if adding multiple dataset benefits or affects the performance of the model. From my observation, in different runs it varies depending on the target dataset and how many and which datasets are used for training and validation.